Statistically, it's safer to fly.
Statistically, it's safer to fly. That's crazy, right? Most people will be fascinated or almost intrigued when they hear this. What? It's safer to fly because the flight seems so dangerous. But why is it statistically safer to fly?
Because people around you are stupid maybe when you're driving. Honestly, airplanes are very controlled. They're inspected. There's tight regulation to certify an airplane to carry humans. Takes a lot of time and effort, and takes a lot of rigor, most importantly. To keep it certified to fly, again, takes a lot of time and effort and rigor. And pilots need to be very good. There's again a lot of time and effort that pilots need to put in, and they need to be very rigorous with their training. So there's a lot of checks. It's a very controlled industry, and for good
standards are very high. Quality standards are very high.
No rain.
Well, hello folks. Welcome to the Naren Agarwal Show yet again. Today we have a genius with us. Yes, I say genius because not only is he my friend, but he is an aerospace engineer. He literally knows rocket science. He is also a flight enthusiast and a pilot, a licensed pilot. I've had the privilege of flying with him and not dying, being alive more than 2-3 times. Welcoming on the show, my dear friend and one of the smartest people I know, Mr. Ujjwal Dalmia.
Thank you, Naren. That's way too much praise, but thank you.
Ujjwal, how are you doing out there in California? You doing well?
Pretty good, yeah. Weather has gotten really nice, so enjoying that.
Amazing, amazing. Well, Ujjwal, let me ask you first. How did you get into the whole aerospace, the flying industry? What enthused you into it? What fascinated you about it? Is it something that you knew from your childhood, or you got into it eventually?
Dude, that's a great question, and I honestly don't have an answer for that. I've been searching for an answer to that question. Um, yeah, just as a child, I wanted to be a pilot. Just like everyone has pilot or firefighter or
astronaut,
or astronaut or something like that. I wanted to be a pilot, and somehow that stuck with me for a while. And then when I got glasses, people said, "Hey, you can't be a pilot if your vision is not perfect and you wear glasses." And I didn't know if that was true or not. But then I just went oh, if I can't fly airplanes, maybe I can just design and build airplanes. And again, that stuck with me, and I followed through with it. I had the support of friends and family. I had the resources, so I just kept going where my heart took me. And today I'm working in the drone industry, and I'm very grateful for that. I'm very happy with that.
Wow, that's amazing. So it's somebody told you cannot be a pilot because you have glasses. So you were like, okay, that's fine. I'll tweak a little bit, but still my love for flights will remain, and I will go into studying and learning more about flights. What's really unique is you're one of those 5% people, I would say, who have a childhood dream like astronaut, fireman, flight, and who stick with it, which is awesome.
Yep.
Which is awesome.
Yeah, and airplanes, I think everyone finds them fascinating, right? Airplanes are just fascinating. And someone recently asked me why airplanes? What fascinates me about airplanes? And I just had one thing to say. It's they're heavy metal tubes, and yet they somehow fly.
That's one way to put it, huh?
I did 6 years of college, and I'm still how does this thing fly?
Wow.
Still just as fascinated, just as amazed by it, if not more.
See, that's very interesting. I know you went to Purdue University, one of the top schools for aerospace and flight science, and then you went to Stanford University for your master's degree in aerospace engineering. Even going through such an education, you're still fascinated about the subject. I think that's what makes it special, and that's what makes you an enthusiast, and that's what makes you become successful in this industry? Because you still have that fascination about it. You're not over it. I think if you were over it, then also your career, whatever, the learning is over.
I completely agree. I still have like it's a childlike fascination with airplanes. I have yet to have that feeling where it's like, oh shit, it's a Monday, or like, yeah, it's a Friday. It's like Friday. Like there's often Fridays where I'm like, I can't wait to get back to work on Monday and like get onto that problem. So
I love
uh,
that.
yeah, not many people already, like not many people know what they want to do, and then even fewer people are able to do what they want to do. So I'm definitely very lucky uh, to be able to one, know what I want to do, and then to also be able to do exactly that thing. So yeah.
Amazing. I want to ask you about a big event that happened recently. SpaceX, which is a privately owned space exploration slash, going out to outer space company, launched its rocket and sent humans after about, I think, 10 years into the outer space. What's so special about SpaceX? Why so much talk? I want to learn from the aerospace engineer himself.
Well, actually, so SpaceX is the first commercial company to send astronauts to space, and they are the first in the in. So the last time astronauts launched from U.S. soil was 2011. We have launched humans into space since then using the Soyuz rockets from Russia, but the SpaceX launch last week marks the first time in the past 9 years that the astronauts have launched from U.S. soil, and that's just an amazing feat because now the U.S. has capability to launch its own astronauts again, which it did not for the past 9 years. Now, like talking about SpaceX specifically, they just have a entirely different approach to everything, and it's definitely not like a traditional aerospace company. They're not boring for starters. They are the only aerospace company that I know of that has a fan following, and
That's true.
like people really are enthusiastic about them, even if like not just like the employees and like the people who are directly related to the company. People all over the world are enthusiastic about the work SpaceX does, and they are like legitimately fans of SpaceX. um,
What do you think brings that? Is it the unique approach that you talked about? I've heard one thing, like, they have the ability to reuse a big part of the rocket. Tell us a little more about that. What's so different than
so
what traditionally NASA or we here in India and ISRO do when it comes to looking at rockets and thinking about rockets?
so the reusability part, it's it's like a feature, but it's really a product the of the company's approach to solving problems. They just approach it with a completely different mindset, where like and like definitely credit goes to Elon Musk, where he just he just thinks of something and like talks to engineers, and like they get all the resources and everything, and they just go out there and do it, versus traditionally, like usually how rockets were designed was, so NASA would come up with a design, and then like they'd have to think about, like, a lot of different contractors and whatnot, and then once they had the design rolling, and like the contractors were already like doing their parts of the subsystems and whatnot, now that like changing the design is like almost impossible at that point for NASA and for traditional companies. Versus SpaceX, they're nimble about it. They start working on a design and they keep iterating. For example, the SpaceX rocket that you watched, that the one that launched last week with astronauts on board, the crew capsule. Previously, it was supposed to be able to land on land rather than use parachutes to come down in the sea and then be recovered. So like if it's able to touch down on land, then it's much faster to reuse the rocket. It's much faster to uh, it's right there. So like you get the astronauts
Oh.
out, you take the capsule into the hangar, refurbish it, and then it's out there again. You can use it again, like
So back
maybe.
in the day, the rockets where the astronauts were, that cell, that capsule used to come and go into a parachute and go into the sea for a safe
Yeah,
landing,
and
and then
so
astronauts would come out. But now SpaceX is trying to land it just straight on the land, kind of like a helicopter in some sense.
that's what they were trying to do.
Okay.
SpaceX, well, so traditional companies, they just discard the entire rocket. Eventually, first, rocket goes up, it discards a small chunk of it. The rest of it keeps going. The first chunk comes back down. Then it keeps going, and then it discards a second chunk, which might come back down to Earth, or it might just stay in orbit. Um, and then, depending on how far you're going, what kind of rocket you're using, you either just discard two chunks, or for the case of the Saturn V, the rocket that took humans to moon, there were five stages to it. And then the part where the astronauts landed on the moon, they left a bit on the moon as well, and stuff like that. So eventually it was all single use. It never no part ever got reused, right? Then the space shuttle itself was kind of reusable, but it took really long for them to refurbish the space shuttle, and it was very expensive to refurbish the space shuttle. And it was a completely different approach to reusability. And then comes SpaceX, and they have this rocket that comes back down vertically, and then they can reuse it within a month, and their costs of being able to reuse it is are really low.
Wow,
So
that's almost like exponentially different than what was being done. That's what makes
yeah,
it so special. So cost,
yes,
efficiency, everything. Wow.
and then the reason they're able to do it, though, going back to what I was talking about, how they're nimble. So they were planning to land the crew capsule on solid ground, right? And then they sort of figured out, oh wait, this isn't really worth it, because it will take a lot of effort to actually make it safe and to make it certifiable. So like making it safe is one step, and then the next step is like convincing other people, convincing the authorities that it is safe. So like they certify you to be able to do that, right? And they determined it will take a lot of effort to do that, and their ultimate goal is to get humans on Mars. And so they determined at a very late stage in the design process, they determined that it's not really worth doing that. And at that point, some like a traditional aerospace like a traditional rocket being designed in the traditional way by NASA, or like the United Launch Alliance or something like that, that would have just kept going with the momentum, like, oh, it's already too far in, like we can't change the contractors for the landing legs or whatnot. And so that would have just been like, okay, we can't really do this. Versus SpaceX was like, it doesn't look good, let's just get rid of it. And then they decided to just recover the crew capsule from sea, and then refurbish and then reuse it for cargo flights later on. So they're able to change their design very quickly, and they're able to test it out very quickly. And that really is one of the biggest differences between SpaceX and traditional
And
aerospace.
I also think it helps to be a private company because we've seen around the world, there's no doubt about it. Whenever the government gets involved into creating something new, in most cases, they're usually very slow, very bureaucratic, hard to move. And this again shows the power of privatization in some sense when it comes to new development and new technology.
That's true, but aerospace also presents some of the one of the best examples of the government getting things done. The Saturn V rocket. Kennedy said, we will put humans on the moon by the end of the decade," and they got it done. And that was entirely a government-run effort. So that's not always the case, but
Yeah.
yes, traditional aerospace, government-run aerospace has become very slow, very bureaucratic.
Yeah.
At that time, it was a different world, and yeah, I agree. Privatization definitely does make a difference.
Wow, that's amazing. I want to touch upon something that you mentioned about SpaceX's mission is to put humans on Mars. I've heard Elon Musk say that humans can live on Mars. And I know nobody is an expert about this because this is a theory, this is a plan or a vision that he has. What's your opinion as somebody who's really been into the subject, who's really dug deep into the subject? Do you think humans can live on Mars or go to Mars? If yes, by when?
Honestly, on that topic, I know just as much as the other, like any other person. It's highly speculative. I could probably comment a little bit on the rocket technology bit of it. And
Yes.
talking about that, the again, like there'll be people who are skeptics about this, but there's another rocket that SpaceX is currently developing, and that's being talked less about. But they're working on something they call uh, the BFR, the Big Falcon Falcon rocket,
Yeah.
and the Big Falcon spaceship. If you know what I mean.
Yes. All the
um,
smart ones will get it, but yeah.
exactly. And so they're moving again. They're moving very fast with it. They've built physical prototypes. They've built. They've designed and tested and test flown what arguably is the most advanced rocket engine ever developed,
Wow.
and they're moving forward with this next rocket very quickly. So it's possible we're like sending a Mars expedition in the next decade. Honestly, that's possible. Like, what's the probability of it? Maybe, like, I would say a little better than 50-50, because there's a lot of there's the rocket technology part of it. Like, do you have something that can send humans to moon? But then the next question is, like, how do you keep the humans alive, right? Like, you don't want dead people reaching Mars. That's not useful. You don't want to kill astronauts. They're talented
Correct.
people. They have families. No one's gonna get on. More, I don't think anyone's gonna get on board the ship if they know they're gonna die. So the biology part of it, the human part of it, that's something that's being researched, and NASA is doing more work in that direction. So they last year, was it last year? Recently, they had this expedition where they had two astronauts stay in space for an entire year, and that was to study the long term effects of staying in space on the human body, both
Wow.
like physical health, mental health, different aspects of it. And the great thing they did was they sent someone who has a twin, right? One of the two astronauts who spent a year in space, he has a
That's
twin on Earth
amazing.
who spent a year on Earth. And so now they kind of have an experiment and a control,
And control, yeah.
and they're it's not perfect, right? Like there's definitely, like, this human on Earth, he
Correct.
has his own activities, his own emotions. Like, there's definitely,
Correct. You cannot have a
but
perfect control for
yeah,
something like this,
but
yeah.
that being said, like, they're definitely m- moving quickly towards figuring out
That's
what are
amazing.
the physical health effects, what are the psychological effects of
Yeah.
long-term space flights, like spending so much time in zero G, etc. Um,
That's amazing. So there's
so
mainly two parts to this: sending somebody to Mars. One is the rocket technology, if the rocket itself can go, and then the second part, which is also very important, you said, is keeping the humans alive and seeing if the biology, everything will work well. Because if you go into outer space and you burst out because of the low pressure, there's no point sending humans there, right? So I
exactly.
think these are
So
very two interesting pieces.
yeah, and like, you don't just want them to be alive; you want them to be alive and well.
Functional, yeah.
um, so I think alive is much easier than alive and well, and there's tons of research going on in that arena, and that's mostly being worked on by the government agencies, by NASA, and the Russian space agency and other agencies that are part of the
Amazing.
International Space Station program. And
Amazing.
I mean, India is kind of doing something similar where while we kind of already have the rocket to send our own astronauts to space, not to Mars, not to Moon, but just to space. And like I'm sure you are aware, and most of your viewers are aware of the Gaganyaan program, where our Prime Minister Narendra Modi announced that we want to send an Indian to space by our 75th anniversary of independence by 2022. And India has the rocket that can lift the payload, the capsule with humans in it. We're currently developing the capsule, and we're also currently having astronauts train to get ready for the program. And uh, currently, the astronauts, there's four candidates, and they're in Russia training to handle the zero G flight and different aspects of training for
Wow.
different aspects of space flight. And then they're going to come back to India and train on specifically the Gaganyaan vehicle, on how to operate it, etc. And like for specifically the
That's
mission they're going to go on.
That's super
And
fascinating. I have a question about the Indian Space Research Organization, the ISRO. It's also very unconventional what the ISRO has been doing in the past few years.
uh-huh.
Basically, they're proving that Indians are the smartest when it comes to doing things cheap, right? We can get
uh,
anything done at a cheaper cost. So that's the image, and that's the thing that we've learned. But how far is that true? And the Mars rover that we sent it at a much cheaper cost than what NASA did. So a few comments about the ISRO and the Mars rover and the effectiveness of ISRO.
ISRO is a fantastic organization. The stuff they've achieved, it's amazing. Especially in the past decade, they've picked up pace. They've been hitting milestone one after another, and the rate of success is pretty high too. That being said, one of the biggest reasons India is able to do things so cheap is because of cheap labor. Um, yeah, like, but I think the company I'm working for, we're working on developing a new drone, and the biggest development cost is the cost of labor. Or when we since it's a startup, we have more transparency, and they present financial details to us every month, and they show what are the expenditures. Literally every month for the past year, the biggest expenditure by a huge margin has been payroll. And
Mm,
not just payroll is part of the cost of labor. Like there's other parts where like you have to provide a good working environment and stuff like that. And India is able to really save on labor because people like cost of living in India is lower, and then
correct.
engineers in India aren't paid the same salaries that they are here. We hear about IITians getting jobs in America where they're paid in over 1 crore rupees per year, and we find that fascinating. But then here in Silicon Valley, almost all software engineers make that much, and that's just, like we just end up spending that much as well because that's how expensive it is to live here.
Correct. Correct.
So
That
it's
makes
not that
sense. So ISRO is
fascinating
about
here.
ISRO can get a lot of stuff done for cheap because of cheap labor. One
Yeah,
last thing I want to hit about space, and then we'll go into flights and aeroplanes. What is the International Space Station? Like we always hear it, International Space Station, International Space Station. Is it kind of like a station where people can go rest, eat food, astronauts who go to space? What is it? What is the International Space Station?
it's an orbiting laboratory. That is the shortest description I can give for it.
Okay.
Uh, so it's a satellite, and so if this is the Earth, it's going around Earth. It's about 200 kilometers. It's orbiting about 200 kilometers above the surface of Earth. And the closer you are, the faster you need to go to stay in orbit. So it's zipping around Earth at around, I might get this wrong, but if I remember correctly, it's at around 17,000 kilometers per hour. I might be,
That's fine, but
I
it's
am
going
not
super
sure about the
fast.
unit. It's just mind-blazingly fast. Yeah, basically. And it's had continued human presence for a very long time. Again, I don't remember the number off the top of my head, but I think it's been more than 20 years since there's been someone on the International Space Station at all times.
Oh, so a
And
human being, a person is always there in the
mhm.
International Space Station. So there's like, do they have kind of a room in it, or uh, who
Well,
manages it?
so it's managed by a group of space agencies, and they have a crew capacity of 6 people at most. Currently, there's 5 people on board, including the 2 astronauts that launched on the SpaceX rocket. And they have it's not like luxurious where like you have a room to yourself, but they have crew quarters. They have a lot of things going on. They have a lot of like, I guess they of course have stuff to support the astronauts that are on the space station. But what would be more interesting and relevant to us is they have a ton of experiments going on at all times. There's experiments related to climate change, like what if we did something different, like maybe we learned something from space that we can apply to Earth to like reduce climate to reduce the impact of climate change. They have experiments, as I mentioned, on uh, like human effects on humans of space flight. They also have experiments where they're growing plants in space. So if we're sending a mission to Mars, maybe we'll have to grow food. Uh, so they have a ton of different experiments. This is a
That's
very
crazy.
small summary. They have a ton of different experiments going on at any given time. And
That's so fascinating. I feel like whenever I speak about space and I get to learn all these things from you, it's like a totally perspective shift. It's amazing. So they're doing experiments of trying to grow plants in space. That's
yeah,
amazing.
and the list is too long for me to even like go through. I would really encourage you to just go watch videos. They do live feeds from the ISS. There's a ton of videos from the ISS about the ISS. I would really encourage you to go watch a few videos on YouTube about the
That's
International
awesome.
Space
I'm
Station.
fascinated. I'm going to do that too. And I'm sure the viewers are going to watch videos of ISS experiments now. Thank you, Ujjwal. Um, Moving on to flights, flying, aeroplanes. Who invented the aeroplanes? Like they say the Wright brothers were the first people to fly the aeroplanes, but I heard there was a person just 2 days before having aeroplanes. What's the story behind it? I find that a very fascinating story.
Well, so the Wright brothers are were the first people to fly, and I would say they are the inventors of the airplane. There was another project that was actually government funded by the U.S. government that was also trying to build a powered flying machine, and it just didn't work. And the Wright brothers got to it first. There's not you could read much more. You could read more about the story, but
That's the short
in
answer.
essence, that is it. Like, I think the most interesting part about this story is that other project was actually U.S. government funded, and the Wright brothers were just doing it with their own money,
Oh, wow.
and they got to it
Again,
first.
we come to the power of privatization. Just kidding.
Yeah,
The other dude probably had to get so many approvals from the government. Shall I move forward with this? The Wright brothers just kept doing it, kept being nimble, as you say, and did it.
maybe
Um,
the other guy got pretty close too. Like, it wasn't like it was a complete failure.
yeah.
Yeah.
Having said that, what's one of the most fascinating things to you about flights? See, we just think in general flying is fascinating, right? Because something is flying, but you really know the deep science of flying, and you are a pilot yourself. I mean, you can make that thing fly. So, so what's fascinating to you? What are some things that are very unique to you about flying?
So I did study aerospace engineering, but aerospace engineering is a field consisting of different specialities. You can do a concentration in controls, or you can do a concentration in structures. What I find most fascinating is aerodynamics, how air flows around, not just airplanes, like how air flows around anything, honestly. But yeah, just you 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 build a shape in a way that like suddenly it goes fast enough, and air is able to generate enough force on it that it can fly. Like, how is air able to do that? And how can we do that better? That's really all I think about. Like, even when I am on an airplane, I you can often find me, if especially if I'm in a window seat, you can often find me just staring outside and like trying to see what different tiny bits are doing to add up to be able to carry you at 30,000 feet above in the air.
That's amazing. So it's about what's really fascinating for you is to figure out as to how the law and the physics works of the air flowing,
Exactly.
and then how can we craft something to utilize that power and that potential. So in some ways, it's kind of like solar energy. You know, there's already energy there, but we are not tapping into it. But if we can find a way to tap into it, we will have better and cleaner energy on Earth. Same way with flights. If we can find out a better way to construct a figure, a structure, in a way, we can use that potential that's already provided by the airflow better and fly better, right?
I guess, I mean, honestly, that's not the best analogy.
Correct.
But it works to some extent, yeah.
Correct. For a
Uh,
person who does not know rocket science, I guess.
yeah.
So, when flying, what are some things that you have to really keep in mind when you're the pilot that the crew or the passenger don't really care about? Um, what are some things
Um,
that you have to be very cautious of when you're driving on the car? You got to always look out for other cars. Is it the same for when you're flying, because there's not much? Or like, what does a pilot look for?
well, once you are in flight, once you're like steady and level, when, for example, your seatbelt sign is turned off. Seatbelt signs are never turned off when I'm flying, because I'm flying a small airplane. Also, you've seen me drive, so you
Correct.
uh, but when you're on an airplane and the seatbelt sign is turned off, well, you could say figuratively the seatbelt sign is kind of turned off for the pilots as well, depending on the flight. So, like if you're on a long haul flight, like the pilots can sort of relax a little bit. There's of course ATC communication. So uh, there's ATC communication, and then monitoring what's going on with the airplane. If something goes wrong, you really got to be ready to take over. And then there's like some level of planning for like what's coming up next, like maybe looking at weather. If you're close to landing, looking at the approach charts, what you can expect depending on the weather, the traffic. You call the ATC and like try to figure out what different paths, out of the different paths, what path they would want you to take when you get in for landing. All of that. It usually does not require as much attention as it would to drive a car.
Now
Uh,
that's crazy. That's crazy for an average person to hear. Yeah.
yeah, you're not constantly looking out for airplanes, because once you're in 3 dimensions, there's a ton more space. That's why you can have so many airplanes flying all the time, and you don't hear about mid-air collisions as often. But and then there's ATC watching out for you.
So
So
when you say ATC, the air traffic control, is this one body? Are these different places? Are these different areas in map? How does this whole network, because I feel like anywhere a pilot is flying, he can talk to somebody. So who is the
Uh-huh.
pilot, or she can talk to somebody? Who is the pilot connected to when he or she are talking to somebody?
So it depends on where you are. Um, I'll give you an example of our flight. When you were here in the San Francisco Bay Area, we took off from Palo Alto. Then remind me, we flew over San Francisco, right? We didn't
Correct.
go to Monterey, right? Okay.
Correct.
So we took off from Palo Alto. We flew north towards the city of San Francisco, and then we kept flying north till we were over the Golden Gate
The Golden
Bridge,
Gate Bridge.
and we did a few loops above the Gate Bridge to get to like enjoy the view, get a few good pictures for Instagram, of course. uh, and then we flew in that general area close to San Francisco over the bay for like about half an hour, and then we flew towards the city of Oakland, and then flew back towards
Correct. Correct.
Palo Alto. Right. So in this flight, when I was on the ground and I turned on the airplane for the first time, turned on the engine and then turned on the radio, I tune into the ground frequency for the airport. So there's a tower at the airport, uh, and there's a person in there who I'm talking to. That person tells me like when I can go to the runway, when I can taxi to the runway. So once I get approval, I taxi to the runway, and at the runway, I do a few tests of the engine and different systems on the airplane. Once I'm done with the tests, I switch over to tower frequency. So tower frequency is basically the controller who's controlling the airspace that belongs to the airport, right?
Okay. So every airport
So
has a certain airspace they are controlling. So when you talk to
yes,
the ground staff, now you're done. You can fly off. Now you go to the tower control, which controls
exactly.
the airspace of all the flights that
Yeah.
are coming in and going out. They keep track.
Yeah, so any flight in the designated airspace for that airport, they have to be in contact with the tower at that airport, the air traffic controller at that airport.
Gotcha.
So uh, after talking to tower, I get clearance for takeoff. They tell me like, oh, you can take off, and then like maybe a bit of instructions on what I should do right after takeoff, like what turns or whatever. So once I take off, and then once I'm outside the frequency, outside the airspace of the tower of this airport, um, you either have to switch to a different airport frequency, depending. So in the Bay Area, we had to switch to another airport frequency because it's a very dense airspace. There's a few airports around, or there's what is called approach frequency. So then it's like a big area covered by one air traffic control center in some major hubs. So like there's a Chicago center, there's a I I think there's a San Francisco center, but so you'd either
Gotcha.
connect to center or approach or something like that. So for our flight, um, and um, almost all the time, the controller you're talking to will tell you who to contact next and on what frequency. So on our flight, next we contacted another airport, San Mateo Airport, and then we contacted San Francisco Approach. And since San Francisco is a big airport, you need clearance to enter San Francisco airspace. So San Francisco Approach gives me clearance saying, and you have to hear these words, cleared into the Bravo. It's called Bravo airspace. So approach clears me into Bravo. Then when I'm about to enter the Bravo airspace, I switch to San Francisco tower frequency. That's the busiest frequency I've been on because that's the frequency all those Airbus, Boeing airplanes, all the commercial jets are talking
Yes.
to. You can you can hear them clear. Like I've literally heard. I think it might have happened on our flight as well, but I've literally been heard the tower say like Emirates whatever cleared to take off, and then I saw a A350 roll down the runway and take off. And then another time, and uh, or maybe this was our flight. I don't remember specifically which
That's fine, no
flight
problem. Yeah.
we were on. But there was another time, and this was like the most fascinating thing that's happened to me while flying. I was so I was to the left of San Francisco Airport. San Francisco Airport is here. I'm flying over here, and then tower tells me do 360-degree loops. So just stay where you are, do a few 360-degree turns, because there's another airplane taking off. And and then they cleared another airplane to take off, and I could see an Airbus A340 take off in front of me.
While you were doing just 360-degree loops in
Yeah,
the air.
yeah.
That's amazing.
So yeah, so we contacted. I talked too much about flying
I see.
there, and not about. I
But,
just
but
got
I
lost.
get this. I get the sense of what you mean. Basically, the air traffic control keeps switching, and every airport has their designated areas where you can then,
Yes.
once you're approaching that area field, you can keep approaching them. And I guess most
Yeah,
of Earth is
and
covered
and
like
then
that.
there's a few centers which control much bigger areas that are not that are not under any airport.
Is it safer to fly or is it safer to drive?
Statistically, it's safer to fly.
Statistically, it's safer to fly. That's crazy,
Yes.
right? Most people will be fascinated or almost intrigued when they hear this. What? It's safer to fly because the flight seems so dangerous. But like, why is it statistically safer to fly?
Because people around you are stupid maybe when you're driving. Well, honestly, airplanes are very controlled. They're inspected. There's tight regulation to like certify an airplane to carry humans. Takes a lot of time and effort, and takes a lot of rigor. Most importantly, to keep it certified to fly again takes a lot of time and effort and rigor. And pilots need to be very good. There's again a lot of time and effort that pilots need to put in, and they need to be very rigorous with their training. So there's a lot of checks. It's a very controlled industry, and for good
Standards are
reason.
very high. Quality
Yes,
standards are very high.
yes. Something I've heard often working in the aerospace industry is you can take a part that costs $10, and then you put it on an airplane, and now it suddenly costs $1,000.
Huh.
And that's not just a saying. That does happen. You'll often see listings for parts which are $10 for standard, and then $1,000 for, maybe $1,000 is an exaggeration, but it does go from $10 to $200 for aerospace parts, because aerospace parts need to be that much more fail proof. uh,
The
and then
quality
there's
check is just
redundant.
exceptional. Yeah.
Exactly. And then there's redundancies built in. So like there's 3 flight computers on every airplane, and if 2 of them fail, the third one can still fly the airplane. And there's a ton of other redundancies built all over the airplane. So that way, if one part fails, that doesn't lead to a crash.
What's your
So
favorite aeroplane?
my favorite airplane of all time. Let me grab a model.
Okay, please, please.
So I have a model and a picture actually. But my favorite airplane of all time is the F4U Corsair. It's a World
Okay,
War II airplane.
okay,
This is a picture of the airplane.
okay.
Uh,
I see. It's got a
and
nice look. Yeah.
Yeah, it's just it's got such a good character, and this is the model. So what I think really fascinated me about this airplane is you see the kink in the wing over
Yes.
here. So it's
Yeah.
called a inverted gullwing design, and I think that really adds character to the look of the airplane. And the reason for that is because the landing gear is placed right where the bend is, right? And
Correct.
the reason the bend is there is so that they can raise the nose and put a bigger propeller on there. And I mean, it's a World War II airplane, so it was designed designed for war, but I mean, it's unfortunate that it was designed to cause death, but it was really good at it. uh, it was good at at what it was designed for, and the Japanese used to call it the whistling death because it had a characteristic whistling sound because because of there's air inlets at the wing root, and because of those air inlets it had a characteristic whistling sound.
That's super
And
interesting.
when the Japanese soldiers heard that whistle, they knew death was imminent.
Oh,
So
wow.
that's why it was called the whistling death. So
Wow.
and
What a crazy story about airplanes.
it was designed for ships, so it can do really short takeoffs and landings. So it looks incredible, and it's really good at what it does. And yeah, that's my favorite airplane of all time.
Thanks for sharing that as well. Last question I have for you is I've seen those model airplanes on the internet in places where everything is almost transparent, where like the
Uh-huh.
floor of the airplane, the sides of the airplane, everything is transparent. Is that just a model, or they're actually trying that? And do you think something like that will come? What's the use of having an almost transparent airplane?
Honestly, I haven't seen what you're talking about.
Okay.
You might be talking about like augmented reality airplanes where like they put screens. So there's been talk for a while in the aerospace industry of having airplanes that don't have windows because like windows are kind of difficult to put on airplanes. They cause stress concentration, and the structure, it has to be stronger around them. So there's been talk for a while about windowless airplanes, and aerospace engineers kind of we find that more fascinating than windows on airplanes, uh,
Great.
as long as we don't have to be in it.
So they're
But
talking about how like the outside maybe can be projected in the screen, so people don't feel like they're claustrophobic or they're clustered, and at the
exactly.
same time you
So
can have a windowless airplane. That's amazing. Okay.
yeah, and there's a few other concepts for how airplanes could look in the future that are like wildly different from what we see now, and some of those designs would require some sort of augmented reality or something like that to make it real. And so I think what you're referring to as like transparent might be the augmented reality
Okay,
airplane.
maybe. I don't know much because this is rocket science.
Yeah.
So awesome. Thanks, Ujjwal. Lastly, I would like to ask: do you have any questions for me? Do you have any questions for me?
But what about communications in aerospace? Do you find most fascinating, especially having overheard my conversations with ATC when we flew, right? What do you find most fascinating, and what did you learn out of that?
Yeah. So one thing is what I learned when I was flying with you and I was hearing the air traffic control. There's a couple of things that I noted about the communication that's supposed to happen. Number one, it has to be very clear. No crap. No filler words. No unnecessary words. It's a very to the point, aimed communication. Second, there's very little margin for emotions and being angry or sad or happy in that way, because you can't bring that in when somebody's focused and guiding a bunch of people. Communication has to be very to the point, transparent. You cannot afford to fight with the air traffic control because you gotta get the information and get things done. So I think it's a very unique way of communication, and I think for pilots that would also be a big part of the training: specific words, aimed communication, and not using too much emotions, because that's not the context that it would work in. So I think that was very fascinating for me.
Yeah, I would say maybe from a layman's perspective it might seem that way, but emotions do sometimes come in. And there's a lot of hilarious YouTube videos uh, of air traffic control communication where there's like either pilots fighting with air traffic control. And there's this one New York air traffic controller who is amazing at his job, and he makes jokes and whatnot. Uh, I
That's amazing, and that
I
makes you
can like
see, like,
forward
it's
you
ultimately us
the
as humans. Yeah,
yeah. It's a very human interaction. At the end of the day, it's all humans involved. I can forward you the name of the air traffic controller. I would again recommend go check out some of the communications videos of this guy talking to airplanes at New York JFK Airport, which is like one of the busiest airports in the world. And like being able to have a like lighthearted joke in his communication there is just crazy, but he does
that's
really well.
that's a
And then
feat.
another thing I would I don't know if you noticed is we never so like one of the things we never do is we never say letters. We'll never say runway. We would never say like taxiway A, taxiway B, even though the taxiways are called A, B, C, D. We say taxiway Alpha, taxiway Bravo, or like my airplane code, the one we flew in was 837SP, but I never said 837SP to the controller. I would always say 837 Sierra Papa. Uh, so there's a phonetic alphabet. Uh, there's words designated for each letter. And so I'll never ever say letters in my communication with air traffic control, because what I say a B and you hear a D, and that could
That's
lead to chaos and
That's
confusion.
really fascinating. So that's
So
great. So there's less margin for mispronunciation and
yes,
miscommunication. So you have a
and
word pretty much prescribed with any letter. So if you want to say S, you say Sierra, not S. You want to say P,
exactly,
you say Papa. Wow.
and I would never say like 16. I would say 1 6, because like what if I say 16 and you hear 13 again? Right,
Ah.
same
So it's
same thing.
flipped with the numbers, and it's with the numbers you say it individually, digit by digit, and with the letters you don't say it letter by letter. You say it word by word in that sense.
Well, no. So like, say I had to tell ATC my name, I would, or like even like say an Adam has to tell ATC their name, and like the ATC guy, for some reason is like spell it out. You would say alpha, like Adam would say Alpha Delta Alpha Mike. Like you know,
Correct.
so even like these are designated letters, and
That's amazing.
yeah,
Awesome. Ujjwal, what a great conversation. We really went in the depths of space and flight science, and thanks for making rocket science a little more understandable for us.
of course. It was fun talking to
Appreciate you
you.
being on the show, brother.
Yeah, thanks for having me.
Hope to see you soon and fly with you soon.